Hello again. Today we're going to talk about multiple transformations on objects on the coordinate plane and describe the transformations and see what kind of figures they produce. Here we're just going to complete a statement so you can kind of see a transformation has already happened. It says triangle ABC can be mapped onto triangle DEF with a reflection across blank, followed by a dilation centered at the origin with a scale factor of blank. Okay, so it looks like this has been sort of flipped over across the x-axis, so we know we have that right away. Then we have a dilation that happened. It shrunk down. And in order to figure out scale factor, remember what you can do is if you have the two objects you're comparing, take a measurement from the second object and divide it by the first object. Let's look at the base of the triangles. If we focus on the base of the big one, it goes from -1 to -8. Okay, that's sort of like our first measurement. A distance of 7. All right, and then it goes down, looking at the base of the smaller one. Kind of hard to tell just by visually inspecting it. However, if we compare the distances between the x coordinates, notice we have a -0.25 and a -2. That is a distance of 1.75. And if we take 1.75 and divide it by 7, you can do that in the calculator, we get 0.25, also known as 1/4. So the measurement of the second object here divided by the first, the base of the small triangle 1.75, the base of the big triangle is just 7, that came out to 0.25. 0.25, we could also say 1/4. The little triangle is 1/4 as big as the big triangle. So a couple things happened here. It reflected over the x-axis, shrunk down by a factor of 0.25. All right, let's look at another example here. We sort of have a multiple choice type question to focus on here. Which sequence of transformations would result in a figure that is similar but not congruent to the original figure? Okay. So basically we're just going to go through each of these statements and say whether it would work or whether it wouldn't work. And right here, let me do this correction. We should have a B here. All right, a dilation with a scale factor of 1.9 followed by a rotation of -30 degrees. Rotating an object doesn't change the size of it. It simply moves it. However, the dilation of 1.9, the object got bigger. In fact, looking for that phrase, dilation with a scale factor, that is going to make this work. We would have two figures that are similar. That means they're the same shape but not the same size. Similar but not congruent. For B, a rotation about the origin of 65 degrees followed by a reflection across the x-axis. Well, a rotation isn't going to change the size, nor is a reflection. So B is not going to work. Let's look at C. Reflection across the y-axis followed by a dilation with a scale factor of 10. We get the object becomes bigger. This would work. The two objects would be similar but not congruent. Finally, a dilation with a scale factor of 0.1 followed by a translation 5 units left. Translating does not change the size, however, any dilation does. So three answers here, A, C, and D, would give us two figures that are similar but not congruent. Let's look at another one similar to this. Which transformations will produce similar but not congruent figures? Kind of the same deal here. For all of these, we're sort of looking for those dilation, looking for that scale dilation with a scale factor. For A, we have a rotation, and then we have a reflection. Not going to work for A. For B, dilation with a scale factor of 6, it got bigger and then translated 2 units down. This is going to work. Parallelogram JKLM is translated 6 units up, then dilated by a scale factor of 10. There's that changing the size again. C works. And then finally D, JKLM translated 8 units left, then reflected across the x-axis. I don't see any change in size. D is not going to work. B and C are going to work here. Alright, and that's our video about multiple transformations. Thanks for watching.